Good evening, everyone, and welcome to the public meeting for the Belmont and St. Asaphs Roundabout project located in Lower Merion Township. My name is Nathan Parrish, and I am the PennDOT project manager for this project. We also have with us the design team from Urban Engineers, including Mike Mastalio, the design team PM, and Mike leads Urban Engineers multimodal projects, integrating various transportation modes into safe, efficient, and sustainable solutions for all users. He has 26 years of experience in project and staff management of complex, innovative, and multidisciplinary transportation studies and projects. Mike has been involved with optimizing mobility and improving safety in the policy, planning, analysis, traffic engineering, geometric design, and construction of innovative intersections and interchanges, serving on the TRB and ITE National Roundabout Committees and giving roundabout training. We also have Andrew Gould, the design lead, and Andrew manages safety and multimodal projects as a transportation engineer with Urban with over 13 years of experience. Andrew's experience covers all aspects of project development and delivery, from design through construction for minor and major complex projects. Recently, Andrew has helped deliver 8 roundabouts throughout the Commonwealth. Currently, Andrew is helping PennDOT deliver safety projects throughout the Delaware Valley region. Just a quick note that this meeting will be recorded and available on the project webpage. For tonight's meeting, if you have a question, please use the Q&A button at the top of the Microsoft Teams window to input and post your question. Questions will be answered by the project team at the end of the presentation. If you have a question about a specific slide this evening, please include the slide number. For tonight's meeting, we will provide a project overview, the project purpose, highway safety manual analysis, roundabout information, design considerations, and proposed design, operations and safety, construction, and finally, we'll take questions from the attendees. Now I will turn the presentation over to the design team and Mike to run through the project.
Yeah, thank you, Nate. Welcome, everyone. Thanks for being here tonight. And if you're watching this on the recording, I hope you find it informative. This safety project is located at the intersection of Belmont Avenue and St. Asaphs Road. Belmont Avenue is a state route owned by PennDOT, and we're in Lower Merion Township in Montgomery County. The intersection itself is 1 block north of City Avenue, and the project is located within the City Avenue district, which is a business district. We've been studying this project since 2019, and we're currently what we call in the preliminary engineering phase. Throughout the process, there's been extensive coordination with Montgomery County, Lower Merion Township, the City Avenue District, and developers, and even some folks at the Sutton Terrace, even before the design received its notice to proceed. We're currently targeting a construction of early 2027. What we have here is a slide that's blown up from the intersection, and what I first want to acknowledge is that through our discussions with the township and the district, we've noticed and been informed of a lot of adjacent development. And through that development, we've discussed how to accommodate for not only vehicles, but for pedestrians and bicyclists. We also are aware of in the future that the St. Asaphs and Clyde Road and the Lamberis and Belmont Avenue Road intersections will have future signalized intersections, or otherwise known as rectangular rapid flash beacons, which aren't currently built yet, but we are aware of those future improvements and have been coordinating appropriately. Belmont Avenue runs north-south or up and down on the screen. It's 4 lanes in each, 4 lanes or 2 lanes in each direction, and it has a posted speed limit of 35 miles an hour. It is a curb section with sidewalk on both sides of the road, and no shoulders are present. St. Asaphs, which runs east and west or left to right, is also 4 lanes in each direction and 2 lanes in each direction with a posted speed limit of 35 miles an hour. This curb section is also curbed with sidewalks on both sides of the road, and no shoulders are present. As part of our investigations and documentation process, what we call the NEPA process, we found that there are no streams or no wetlands and one property of historical significance. The one Belmont, which is documented in the southeast quadrant, is an eligible resource, which we are calling the Barclay Building for its historical properties. Throughout our data collection and our field visits, we've observed some very high running speeds. The intersection is underperforming operationally and has high occurrence of injury crashes. There are existing crosswalks on all 4 legs, ADA ramps, and we've heard many concerns about how to cross the intersection as a pedestrian and a bicyclist. Right now, the intersection processes, I would say, about 28,000 vehicles per day, which are evenly distributed amongst the 4 legs. Moreover, what we've observed is a large percentage of of left turn movements. And you can see in the top left corner here, we have peak hour turn volumes. And so that's the worst hour of the day. And so when we have large amounts of left turn volumes, it's tricky to process all of that traffic. Next slide. Since the safety funding was awarded, the design team has been coordinating with Lower Merion Township and the City Ave District, as I mentioned, and to ensure the design accommodates the future developments as well as the master bike ped plans for the area to really help out with those first mile, last mile connections associated with transit routes. PennDOT has revised the design a few times to include what we're calling a public multi-purpose path that is displayed on this mainline greenway map that Lower Merion Township provided us. Here's a snippet of the City Avenue District official map, which was adopted as an ordinance by Lower Merion Township through Zoning Code 155. As mentioned, we've been studying the intersection studying intersections throughout the 5-county region, otherwise known as PennDOT District 6. And the goal of the program is to address safety needs at intersections by identifying locations where a roundabout would be suitable for what we call safety countermeasures. What we are trying to do is qualify for highway safety improvement funds, which are part of an FHWA program and are 100% federally funded. And so the applications for this funding had to really be data driven. And so we looked for roundabout candidates based on crash clusters, and that's how this intersection came to be. As I mentioned, we had high running speeds and a large number of left turns, so it's no surprise that this was one of the worst intersections in Montgomery County from a safety perspective. Andrew, do you mind showing and walking through the slide here?
Yeah, sure. Thanks, Mike. The intersection was selected by PennDOT as a high crash location in a 5-year period, which is a typical time frame that PennDOT analyzes crash statistics. The intersection had 37 total crashes. Of the 37 total crashes, roughly 53% had reported injuries. 88% were angle crashes, and 91% of the overall crashes had no weather or no environmental factors. So with this data, it was determined that the intersection needed improvements and that a majority of the crashes were not impacted by weather and was likely due to conflicts. Those conflicts Mike's going to highlight a little bit later in this presentation. The purpose of the project is to reduce the number and severity of potential crashes at the intersection. An additional goal of the project is to improve the pedestrian connections and to accommodate the nearby development. As part of preliminary engineering, the design team conducted an HSM, a highway safety manual analysis. There was a lot of concern from the township and PennDOT of the evaluation of a traffic signal, comparing it to the benefits of a roundabout. The township shared with the design team a study that was conducted through the PA Act 209 in 2011. That study that was prepared had a signal alternative shown here in orange. And that alternative included left turn lanes at the intersections to relieve congestion. As part of a safety screening, the HSM analysis was conducted using that 5-year crash period that I previously mentioned, from 2017 to 2021. The HSM screening injects all the crashes into a worksheet that is then analyzed with the recommended alternatives using crash modification factors, or CMFs. These crash modification factors are studied at a federal level to determine crash reductions that are expected for specific design features like the installation of a roundabout or the installation of left turn lanes for that signal alternative. The output of the analysis compares the total crashes versus the existing crashes. Based on the crash characteristics of the intersection, the inclusion of left turn lanes actually increases expected crashes at the intersection, while the roundabout reduces crashes. That is why the roundabout is the best option from a safety perspective for this intersection. And we have to remember that this is a safety-driven project. Now I'm going to pass it back off to Mike to kind of get into a little bit of a roundabout education here.
All right, thanks, Andrew. So why a roundabout? I think for the most part, that's a big question we've heard from a lot of folks that are on the call tonight. And one of the reasons why we are analyzing and moving and suggesting a roundabout is because roundabouts slow people down. They provide deflection and yield, and every year, PennDOT goes through their highway safety improvement program and looks at their safety statistics of existing roundabouts. But what's really adequate is that FHWA has a proven safety countermeasure, and so we've roundabouts have been proven to reduce serious injury crashes and non-serious injuries by a large percentage. And the reason is because, if you go to the next slide, Andrew, is because we've standardized the rules of the road. We yield on entry and we provide deflection. You're just not physically able to drive through the intersection at a fast speed. And that's because you have to turn your wheel. Also reducing those conflict points and eliminating what we call T-bone crashes or left-handed turns where we have those conflict points. Next slide. And so as you can see here in this graphic, we all know that speed kills. And so as the speeds are increased, the percentage of being injured for a pedestrian increases. And as you get to 40 miles an hour, 9 out of 10 pedestrians will die if hit at going 40 miles an hour. Roundabouts, when we design them, we've reduced the operating speeds to around 20 to 25 miles an hour. I really like this graphic here. This was something that the Utah Department of Transportation has put together. And when we talk about conflict points, when you look at a conventional intersection, there's over 32 conflict points that are all in the intersection itself. And so one way to think about it is the roundabout takes away or eliminates those conflict points and almost alleviates those left-hand and T-bone conflicts. And so we've been able to reduce the conflict points by a factor of 4. The next slide here shows what a traditional intersection has for a conflict points of 32 versus 8. Now, we all are under the impression that this is not a single lane roundabout, and that is true. We're talking about a multi-lane roundabout. So we are reducing the conflict points from 32 down to 24. That's for vehicles. Now, for pedestrians, we also have quantified, and this is straight out of the roundabout guide, the conflict points associated with pedestrians has also been reduced from 32 down to 16 with our multi-lane design. So roundabouts allow drivers to focus on pedestrians and vehicle movements separately. What we do when we're designing for crossings is that we've focused the driver's attention on the crosswalk first by staggering the location of the crosswalk from the yield bar. That allows the drivers to first focus on the pedestrian crossing and then to move forward and focus on the task at hand, which is yielding to the circulatory roadway. Additionally, we've taken that crossing distance and we've reduced that. So from a conventional intersection, instead of crossing two directions of traffic, we are now only crossing one direction of travel. And the reason is because we introduced these splitter islands or refuge areas in the middle. So a pedestrian will be able to cross one leg at a time and focus their attention on one direction of travel. Having shorter crossing distances allows us to provide to give the pedestrian a little bit more sense of safer feel for crossing the intersection. Additionally, our intersection here will be introducing what we call rectangular rapid flash beacons on all the entrances and exits. And so here are examples of two rectangular rapid flash beacons that have been installed in the community. One of them is just upstream along Presidential Boulevard. There was a road dye that was installed a few years ago, and this is up near City Avenue at the crest of the hill. And so you can see on the left, we've reduced those crossing lengths and provided refuge in the middle, similar to what we're showing at a roundabout. And the yield compliance from FHWA is over 98%. On the right is another example of Ardmore on Lancaster Ave. This is a mid-block crossing, and it crosses 2 lanes in each direction for a total of 4 lanes. And so again, we're noticing large yield compliance and the ability for pedestrians to cross in an area where there's not an intersection to cross at, and there's a lot of need here. So I think most of us are familiar who live in the area with these 2 crossings, and this is what you can expect to see at within our design. So I think what everyone's really waiting for is to see exactly what it is we're proposing. This Andrew's going to walk us through some of the design attributes of our design, and we're going to show a video later on that actually shows traffic simulation.
Yeah, thanks for explaining how we got to this point, Mike. Now let me get into some of the specifics of the design. What you see on the screen is the current proposed design concept. This was developed after a few iterations were discussed with local stakeholders in PennDOT while acknowledging the existing and future developments in the area. Additionally, we're balancing slower expected speeds and accommodating large vehicles, and then also being aware and conscious of the need for safe pedestrian and bicycle crossings. Now in this graphic, we overlaid all of the proposed development. The proposed roundabout accommodates all of the adjacent developments. We are able to not only maintain but improve the proposed access points with the slower speeds around the roundabout to have the safer ability to judge vehicle gaps. The design team has been in close coordination with the township regarding the surrounding developments throughout design. To the west and north, you'll see 2 rectangular rapid flashing beacons. These are proposed. They are not out on the roadways yet, but they are proposed through development with the township. And just wanted to note that they're not part of this project, but we have been including them with our operational analysis. They're still in the planning phases. Now we're zooming into the proposed roundabout intersection a little bit here. Due to the even distribution of traffic on Belmont and St. Asaphs, as Mike mentioned earlier, this is going to be a proposed 2-lane roundabout or a multi-lane roundabout with shared through and left turn lanes and shared through and right turn lanes, as you can see in the pink highlights here. The intersection is located on center of the existing intersection to reduce and minimize the conflicts to the 4 quadrants. Sidewalks and crosswalks are proposed on every approach and in every quadrant of the intersection. In the center here, the green circle, now a yellow circle. This is going to be a raised proposed central island, currently shown in green for grass. However, this is an opportunity that the design team will coordinate with the township to install landscaping, which will also include a maintenance pad for safe access to the landscaping. This provides a great gateway opportunity for the township. Since the project is exceeding an acre of earth disturbance, we are required to manage stormwater through a proposed stormwater management basin located in the northeast quadrant, shown in light blue. A lot of the concern from the township and the locals throughout design has been pedestrian mobility. As part of coordination with the township, PennDOT has committed to install rectangular rapid flashing beacons on all of the crossings. At these, you will see yielding compliance has increased up to upwards of 90% based on what Mike mentioned earlier from federal highway studies. Additionally, Mike also mentioned our coordination with the township and the City Ave Business District to ensure that the design accommodates the Mainline Greenway Master Plan. Through this coordination, we've revised the design to include a proposed public multi-purpose path that is displayed on the graphic in purple. So here, this is the project again. And now I'm going to be highlighting the proposed purple path that matches the Lower Merion Greenway proposed. The required cross sections for these paths are going to be based on the zoning code, chapter 155 for the township. Another design element that's included with this project for additional safety is the inclusion of intersection lighting. As part of PennDOT policy, it is required to illuminate roundabouts. It is recommended to illuminate roundabout intersections. The lighting is proposed to highlight key features of the roundabout, the entries, the exits, pedestrian crossings, and the circulating traffic. The lighting is directed towards the roadway, and it is contained within the footprint of the roadway with minimal lighting to the surrounding properties. As you can see in the photograph, this is an example of an illuminated crosswalk to improve pedestrian visibility at night. Based on the approach roadways and adjacent development, we have 3 scenarios of lighting. In blue, we will see existing lighting that is going to be mounted on existing utility poles. In yellow is new PennDOT installed light poles, and in orange here we have 2 existing private development light poles that are going to remain intact. As design progresses into final design, we will also coordinate with the township and PennDOT to discuss lighting preferences for pole and mounting types and specifications. This allows the project to install lighting that will be consistent for the area and the future development. So how did we get to the footprint that I previously showed you? As part of our roundabout design, one of the main design features is establishing your design vehicle. And a design vehicle is a large vehicle that is likely used to utilize the intersection and ensure that the design can handle it within the curb-to-curb footprint. In this graphic, you'll see one of many of the turning templates that the design team has generated to ensure that the footprint accommodates all movements for the design vehicle. For this intersection, the design vehicle is what is called a WB62 with a 53-foot trailer. It's one of the largest tractor trailers you'll see on the road. As we advance to final design, we would like public input on any unique design vehicles that may need to utilize the intersection. This can range from horse and buggies to farm equipment to unique emergency service vehicles like large fire trucks. Should you know of any of these, please submit this when you fill out the comment card on the project's website so it can be documented and reviewed by PennDOT and the design team. Next, we'll pass it off to Mike to discuss some of the operations from a traffic analysis standpoint.
Yeah, thanks, Andrew. Be able to get my lights to turn back on. So one thing to note is we've been discussing and talking and coordinating with all the future development. We mentioned the 3 quadrants of Bala Kinwood Shopping Center, the 1 Belmont, and then 1 Bala Plaza, all being redeveloped currently and in the future. PennDOT projects typically are designed around a 20-year design horizon. However, we've taken a look even further and done some sensitivity analysis to look at how the future development will and inject that traffic from that development into our models. And so after we get through this slide, you'll start to see some of that actual simulation in the design year that's 20 years out. The purpose of this slide is to really acknowledge some of the concerns that I think we've heard about installing a roundabout amongst signalized intersections. And so what we wanted to do is try to explain and educate you all on how the roundabout will operate. And so we're expecting the roundabout to be opened as a 2-lane roundabout in every direction. That means 2 circulatory lanes, 2 entering and 2 exiting lanes. And with that additional traffic that the developers are anticipating, we've then run what we call a simulation and checked for the operational piece. And so with roundabouts, we have yield control. So naturally, any queuing that may occur is a rolling queue. And we also look at the peak hour. So the highest hour volume of traffic in the AM and in the PM. And usually we can disseminate and we design around that peak hour. Within that peak hour, we look at that hour in 15-minute segments. And when you look at the blue and the purple lines here, what we found is that when you look at the worst case condition, the worst 15 minutes of an average day, is that we're seeing average queues during those 5 to 10 to 15 minutes, anywhere from 115 feet to 140 feet, with the eastbound leg or the east leg having the worst queuing. And that queuing is a rolling queue, so that's why we dashed it. That anticipated queue will dissipate within five or so minutes, and the queuing that we see from the signals when they're hitting a red is the purple. And so you can see here, we don't really have any indication that this roundabout will back up either from itself or from the future development or from the other signalized intersections that are upstream and downstream. And here's a blow up of those peak hour, if that peak hour in the PM in the design year in 2047. And you can see here that blue queuing line, it represents that yellow piece of the graph, which again is about 2 minutes long before it dissipates. And with that, let's get into the video or the simulation and see how this thing is going to actually operate. So a couple of notes here as we're going through the simulation. First of all, this is in the design year of 2047, and that the speeds of the simulation here, we've sped it up at 1.5 times. It's like listening to your podcast a little bit more quicker. But what this is this is what the projected traffic will look like in that design year in the PM. So this is the worst case condition. This shows that top 15-minute peak. And just want to make sure that everyone can see this because we are streaming it. It may come across a little choppy, but I think for the most part, you'll get a really good sense of how the roundabout will operate. You can see here we have the rectangular rapid flash beacons at the crosswalks. We also are showing those multi-use trails, the darker. I think I saw a question that we can get to and posted. These trails and sidewalks are anywhere from 10 to 12 feet in width. And then we do have a buffer, a grass buffer there to provide a little bit more comfort, but also areas for snow removal and signage, and to give the pedestrians more of a safer feel. Like I said, we've been coordinating with the development. That one Belmont is being proposed to be right up against the street. And so we've worked hard with those developers to make sure that the design is going to work with the proposed development. You can see here some of the larger trucks going through those WB62s with the 53-foot trailer. And I think everyone probably is seeing some of the queuing on that east leg and how it will dissipate. The simulation also here will show how a pedestrian would cross. Again, note that this is 1.5 times speed, and also it might come across a little choppy due to the streaming limitations that we have. You can see in the northeast quadrant there, we have a stormwater basin, which will help with some of the erosion and sediment control during construction, but also after and the final condition.
Before we jump to the next slide, Mike, I just want to note that this video does come across choppy a little bit through this Teams Live feature, so the video will be posted to the PennDOT website after the presentation.
Thanks, Andrew. So for those who have never driven a roundabout or aren't familiar with them, the closest one that is near this project is up in Walnut Lane, near the Walnut Lane Golf Course. It's about a 5 to 10 minute drive up Lincoln Drive. And if you zoom into the next picture, it is not a multi-lane roundabout, but it is a modern day roundabout. And so you can see how it operates. This roundabout doesn't have crossings on all 3 legs, but it does have the multimodal piece. But you can see some of those elements like the mounded inner circle and the deflection. And so you're just not able to drive straight through the intersection at a high speed. By having slower speeds, we're really able to slow and have folks feel and judge gaps in the traffic stream much easierly because the speeds are slower. Acknowledging that this is a single lane roundabout, I think it's important to show one that has been built. This is what we call the Big I roundabout. It's in the northern western part of the state. It has very similar context. As you can see, all 4 quadrants have pedestrian crossings. And this one was completed in 2020. And as of now, there's been no serious injury crashes or fatalities with pedestrians. And so this is a really good example of a multi-lane roundabout that has been built on the state network. And just to kind of give you another sense of other roundabouts that are multi-lane with 2 lanes circulating, 2 lanes entering and exiting. This is a project up in Malta, New York. It's actually in a series of 4 or 5 roundabouts in series. And this one shows, again, the multi-lane crossings and has great similar context to the Belmont and St. Asaphs location. With that, I think the last piece that we really want to educate and explain is our proposed solutions to construct the project and the schedule associated with it. Andrew, do you mind walking us through a few of the options that we're considering?
Sure, thanks, Mike. Yeah, so the design team's currently evaluating the constructability of the roundabout, and we're recommending either a full detour or a partial detour option. This detour map is just showing an option of what a full detour may look like, which would allow construction to be completed in a single construction season. The full detour option will improve the efficiency and the safety for the contractor, resulting in a construction cost coming in roughly 10% lower than the phased option, and also an overall shorter duration of the closure. These options are still being discussed internally at PennDOT through the traffic unit, and PennDOT wanted to present these options to the public for just public input. Fully phasing the intersection with no closures would not be possible due to the location of the roundabout being in the middle of the intersection and the limited right-of-way for the project based on the adjacent development. Next, I'm going to get into what the partial detour option through 4 construction stages looks like. Basically, I'm going to run through 4 slides here, just laying out how this would be built utilizing a partial detour, which will be closing the St. Asaphs Road eastbound and westbound legs. During stage 1, the contractor will construct some minor temporary widening on the the southbound Belmont Ave. It'll be done utilizing short-term traffic control, so minimal impacts during this stage. During this next stage will be the largest stage of the project. We will be detouring St. Asaphs Road. This detour for St. Asaphs Road will be done through stages 2 through 4. The detour routes utilize Conshohocken State Road, Route 1 or City Ave, and Kings Grant Road. Again, to remind everyone, the design team is recommending a partial detour to shorten the duration of construction and provide an easier, safer work area for the contractor. And also to eliminate the temporary intersection control at the intersection itself, which would be a temporary signal, and that would drastically impact the intersection to jam up during construction. All traffic will shift to the western side of Belmont Ave during this stage, with lane closures to a single lane in each direction. This allows the contractor to construct a majority of the required drainage, stormwater management facilities during a single stage. Access to the southeastern quadrant property driveways fall within the work area, as I can note here as I'm highlighting, and these will be done through sub phases to make sure that they have access throughout construction. I would like to note that while St. Asaphs Road is going to be closed to vehicular traffic, the sidewalks will remain open throughout construction with minor interruptions and minor detours. On stage 3, we're going to be shifting the Belmont Ave traffic to the eastern side of the roadway, utilizing the newly constructed portion of the project and some temporary pavement. St. Asaphs Road will still be closed for this phase. For ease of construction and intersection control, Belmont will not allow for turns at the intersection and will just allow the northbound and southbound through traffic. Again, this will be evaluated for further and final design if certain movements need to be opened or maintained during some specific phases. And stage 4, we're going to utilize the roundabout circulatory roadway and maintain that northbound and southbound Belmont Ave movements with the single lane operation. St. Asaphs Road again will be closed during this phase under detour. Again, there are going to be no turns allowed at the intersection just to make it easier and safer. And part of this is going to be installing the splitter islands, the central island, and some outside curb work that was used to shift traffic in the previous stage. The final stage after this, stage 4, is just a final milling and paving of the final wearing course, the final pavement markings, the final signage, and then the landscaping, which will have a typical 1-year warranty. Next, we're just going to get into kind of what's next for the project. Mike, do you want to take this one away?
Yeah, so last but not least, I think we're trying to give you a sense of the project timeline as we move forward. We mentioned we were in that preliminary engineering phase where we're finishing up our environmental studies, having this public engagement piece. We do have some final design activities and some permitting to work out, but ultimately the project is scheduled for construction in the spring of 2027. The last few years, we've spent a lot of time studying and analyzing and trying to better understand the needs of the community. And I think with that, Nate, we'll turn it back to you for questions.
Thank you, Mike. So with that, we're going to start responding to the questions that have been posted in the Q&A. Also, please keep in mind if you're able to navigate to the project webpage, There is a comment form where you can ask additional questions and continue to provide feedback on the project and the presentation this evening. So with that, I'll start to read the questions and then we'll respond. I'm going to read the questions in the order that they were received. All right, so the first question. So my name is Nancy Goldman. I am the president of Sutton Terrace. We have 172 units. Many are represented at this meeting and over 40 people are attending in our social room. Chris and Jillian have spoken about the importance of connectivity and walking and biking in this community, getting to the new exciting developments. We have significant safety concerns about our roundabout for pedestrians, bicyclists, and cars, especially since it is now a 2-lane roundabout. The least safe according to the articles I have read. With all the planned development on the 3 corners, there will be even more traffic. The Ballot-Kinwood Neighborhood Coalition consists of more than 1,000 concerned voters and taxpayers residing in more than 750 homes in the community, including Sutton Terrace. The Fairmount 191 Presidential, I apologize if I pronounced something incorrectly, the Trianon, the Corinthian, Hillgate, Minford, the Court of St. Asaphs are also local preschools, a law firm, and single-family homes. In March of 2022, following the last PennDOT meeting, we sent almost 500 signed petitions to PennDOT, our commissioners and local officials asking for a safe pedestrian, bicycle, and car-friendly neighborhood. We asked the Township to work with our elected officials, Township staff, and PennDOT to benefit everyone in Lower Merion, a safe community. We are disappointed that in the last 2 years, there has been no discussion with us, the very residents who will be affected on a daily basis by those decisions. And unfortunately, this format does not allow for discussion. Although the roundabout is obviously not good for residents of Sutton Terrace, it is also not good for the local community and for, sorry, I scrolled down, for the larger Lower Merion community as cars try to get through this roundabout into the rest of Lower Merion Township. And we strongly request dedicated left turn lanes instead of a roundabout. Well, we definitely appreciate, the feedback, the input there. We want to hear from the community around this project, around what the needs of the project are. So we definitely appreciate that input. I know I can say we have been working with, stakeholders in the area on the design. I can comment that, we have had individual meetings with residents and some of those in Sutton Terrace itself. And I know this comment was posted earlier on in the presentation. So hopefully some of the comments there, we've kind of discussed in the presentation itself. But I guess, Mike, you just want to touch a little bit more on the pedestrian aspect of it, and I think there are some subsequent questions on the same issue.
Andrew, if you don't mind going back to an earlier slide that showed the pedestrian crossing in the maybe the proposed design, where you kind of highlighted some of the different attributes. Again, I want to reiterate that we're trying to slow speeds down. We observe very large running speeds right now, very high running speeds. Additionally, crossing the intersection right now is not advantageous. And so what we're trying to do is make it more accommodating for the other modes of traffic. We're trying to improve operations, the safety, and the multimodal piece, which is the bike and peds. And then there's a fourth attribute, and that's access. And I want to address the access because I don't think we completely hit that in all of our slides. But by slowing vehicles down, and shortening the crosswalk distances, and then reinforcing the crossings with these rectangular rapid flash beacons, we're able to reduce the overall distance that pedestrians need to cross the intersection. And so we're providing 2 crossings that are 24 feet in length versus the existing condition, which is 4 lanes times 12 feet. That's over 60 feet of pavement of travel to cross, which does then also take away from the vehicles being able to go through the intersection. So these are shorter crossing distances with slower speeds, and we're focusing the attention in one lane in each direction, or in one direction. So 2 lanes of crossing, you hit the splitter island or the refuge, and then you focus your attention on crossing the second. So we're segregating that crossing into 2 separate crossings, and we have the push button controls with the rectangular rapid flash beacons, which has been shown and studied that the yield compliance there is very high. The other thing I want to acknowledge is Sutton Terrace does have 2 access points. And so one advantage of the roundabout is that you'll see slower running speeds as vehicles leave the roundabout. Additionally, if you don't feel comfortable exiting out of your community or your parking lot, you'll be able to use the roundabout to travel in any direction that you want. So you can take a right out of onto Belmont Avenue and use the roundabout to your advantage to go in whichever direction that you are trying to travel in. I think that's an important message here that we want to use. So I think at the end of the day, we're hoping that this educational part that we've gone through is really providing you an opportunity to understand the benefits from a pedestrian and bicyclist standpoint.
Mike, are you able to, so the next question I just wanted to touch on are roundabouts only work on low volume, low population areas. Why are you contemplating a roundabout in a high volume car and high population area?
I think the reason is for slowing speeds down and trying to allow folks to judge gaps more adequately. Again, eliminating those left turn conflict points will reduce the severity of crashes. There are many cases where multi-lane roundabouts have been installed and successfully are working today.
Next question is, where is the funding coming from? What is the source of the funding? So this project is a safety project, and it is funded with federal money that is specific for safety improvement projects. So when it's a safety improvement project, everything we do has to show a safety benefit, and we have cost benefit calculations that we have to complete that show the cost benefit ratio is above a 1. If a project is not above a 1, then we cannot use the safety funding for the project. And so, the roundabout that we're, proposing here shows a safety, a cost benefit ratio above a 1 with the reduction in crashes. It's also a reason why the signal improvements aren't appropriate for this intersection, is because we're showing an increase in crashes. And so with this type of funding, we're not permitted to do improvements that aren't showing a reduction in crashes. Otherwise, there would be no funding for the project itself. Next question, how much of the stone wall on the corner of Sutton Terrace will be removed? I guess Andrew or Mike, can you just touch on that briefly?
Sure. We have a lot of competing elements at the intersection, and ultimately we've tried to reduce impacts to all 4 quadrants while trying to accommodate the future developments. That said, we tried to also accommodate that multimodal piece with the trails and the multi-use trail network. Ultimately, we really tried hard to not impact any of the circulation or parking spots along the Sutton Terrace circulation. However, the corner of the intersection, as you can see, is impacted. Andrew, do you have a rough number there?
I think it was around 150 to 175 feet. And we'll work through the right-of-way acquisition process with the property owner should they want to maintain or retain the stone material to rebuild the wall, or the contractor to remove it from site.
Yeah, originally we tried to stay completely out of all the parcels, but it's physically impossible. And so rather than having long lineal impacts associated with adding left turn lanes, we are now localizing the impacts to the actual node rather than the lengths of the intersection. And so we've been able to localize and make the improvements to achieve the purpose and need by reducing the length of the project on all 4 approach legs and really focusing the improvement at the node.
Right, next question. How do you explain New Jersey eliminating roundabouts and installing traffic lights for years?
Yeah, it's a great question, and I think it comes up a lot, and I think it has to do with understanding the differences between what a modern day roundabout and an old rotary or traffic circle that you are referring to. Andrew, if you can go back to that slide with the why a roundabout. In general, the traffic circles that you're referring to in New Jersey that have been retrofitted or eliminated, are usually in size over 200 feet in diameter. What we're looking at is like 200 to 400 feet, if not larger. Also, we've tried to standardize the rules of the road. As you approach the intersection or the roundabout, you are always going to yield to the circulatory traffic, and that wasn't always the case. So the long and short of it is that the old traffic circles have outlived their useful lives, and mainly it's because of the size and girth that they were installed with. Also, there's some cases of stoplights or yielding to entering traffic versus circulating traffic. So we've really tried to standardize the rules of the road. There's a reason why the federal government, FHWA, has installed this safety countermeasure on roundabouts. It's because they have been proven to reduce the societal cost associated with severe injury crashes. And that's one of the major benefits of a roundabout.
Next question, what is the turning radius required for a 60-foot tractor trailer? I guess, Andrew, can you pull up again the diagram or the slide on the truck turns and just go over that?
Yeah, while he's doing that, I can try to answer. There is a minimum radius, but it depends on the speed that the truck's traveling and the angle and the approach. It has an axis length. That's where the 53. So we measured from the kingpin to the rear axle group, and what we use is a program called Auto Turn to model it, and it simulates how the driver would navigate through the roundabout. Those trucks directly compete with us trying to provide deflection and flare and allowing for slower speeds. And so we have a balancing act of accommodating the larger vehicle while also trying to make sure that at the non-peak times that vehicles like passenger cars at midnight or 2 in the morning can't blow straight through the intersection. Andrew, did you have anything else you wanted to add?
No, unless the comment is also trying to reflect 2 tractor trailers in the roundabout at the same time. And if that's the case, likely drivers are going to take over the roundabout themselves and traverse and navigate their turn and then exit the roundabout. There have been roundabouts that have been designed to accommodate what we call side-by-side movements of 2 trucks navigating next to each other. And through studies, it's just not the case of what actually drivers do.
I used to live in New Jersey years ago when roundabouts were called circles. They spent years removing the circles due to safety concerns. Why not try a phased approach to this intersection, like left turn signals, to see if it works before installing a dangerous roundabout? Well, with the purpose of the project being to reduce crashes, and with the safety funding we have for this project, we're really seeing, no safety benefit to modifying signal in, the traditional approach you might think of widening or modifying signals at this intersection that are showing a safety benefit. The roundabout is showing a safety benefit and a reduction in crashes. That's why the roundabout is being proposed at this location. a location of which we can observe a roundabout of a similar intersection with a similar volume of traffic. Can we just go back, Andrew, just to the examples again, just let people take a quick look at some of the examples that we showed during the presentation.
Yep, so the Big I is in Vernon Township in northwest Pennsylvania. That's a PennDOT project. And then we also showed a roundabout in Malby, New York. That Malby's about an half an hour north of Albany.
Next question is how much land will be taken from each of the corners of the intersections. I don't think, and Andrew and Mike, let me know if you disagree, but I don't think we've calculated the exact areas yet of how much land will be taken. I mean, there are definitely impacts at each of the four corners of the intersections, to build the roundabout with how we're currently proposing to build it. Is that a fair assessment?
Yeah, we're still in preliminary engineering, and up next we'll be getting into final design, which is the right-of-way process, and that's when we'll really fine-tune the impacts to each parcel.
I will add that I feel like the right-of-way associated with the roundabout, and when you compare it to a signalized intersection when adding the left turn lanes, is comparable. So it's not as simple as just adding a left turn lane. There is right-of-way and constraints associated with both added in the safety benefits that we showed in slide 11, Andrew, with the pedestrian or with the signalized showing an increase in predicted crashes. I think like an interim improvement, it just isn't feasible.
Next question, according to the 9/2021 PennDOT list of roundabouts in the state, there's not a single site that is comparable to the proposed intersection at St. Asaphs and Belmont. Most are in less densely populated areas. The only ones in urban settings are located at complex multi-leg intersections. Is this intersection the only one that is in an urban setting? And I think it means with multi-lane in an urban setting. Mike, do you know of another?
Sorry, Nate. The Big I is definitely in an urban setting, as well as the Malby intersections. Very similar context to St. Asaphs.
I am familiar with successful roundabouts. For example, the Route 222 corridor between Kutztown and Reading was a constant problem. Every intersection would back up. 222 is heavily trafficked road. The roads feeding in are rural with much lighter traffic. This is a very different situation. Both Belmont and St. Asaphs are heavily traveled, and I fear that this will lead to quite heavy traffic in the roundabout, endangering not only drivers, but also pedestrians. Heavy traffic coming into the roundabout will not be stopping and will be coming from four directions rather than two. Blinking lights are not a solution for pedestrians. Every pedestrian who presses that walk light will be causing a traffic jam in multiple directions. That, of course, is assuming that the cars will stop, which I doubt. I mean, Mike, can you just touch again on some of the
actually benefits? Was heavily involved in the 222 corridor roundabout implementation. Those intersections have a little bit different context, but they do have more volume than what we're seeing at this intersection. Those intersections have a very high throughput in one direction and a very small demand in the minor leg. 222 is ultimately going to be widened to 2 lanes in each direction, which is why those roundabouts were built as what we call hybrids or 2x1s. So there's just no need for those intersections to have 2 circulatory lanes in that minor leg, because the demand is not quite there. But from an overall traffic volume, those intersections have more volume than St. Asaphs and Belmont. But one of the biggest benefits of implementing roundabouts is when you have even distribution of of volumes per approach leg. And that's again because of the high number of left turns that we have. Accommodating left turns at a signalized intersection takes away from the ability to also go through the intersection. So by having this holistic design with yield control, we're able to actually have better operations that are safer and more efficient.
Like, I think that's touching on the next question as well, is how do roundabouts affect the amount of traffic that can be handled? I guess, how do they typically compare to a signal in terms of traffic operations?
Yeah, it really comes down to that left turn percentage. So that's a really tricky question to answer. But as I mentioned, when you have even distribution of legs, it adds a heck of a lot. It adds a lot of benefit because now you're able to process the through, the lefts and the rights all at the same time with the circular intersection while reducing those conflict points and slowing those speeds down.
All right, next question, and I'll try to summarize just to, so each, there's 2 lanes entering and exiting the roundabout, and there will be a nonstop flow of cars. How will cars get out in these roads if there is no way to stop traffic? And how will bikes and pedestrians cross the streets? I guess, can you comment a little bit on, I guess, how the flow of traffic will be for, I guess, exiting, maybe on some of the approaches or the departures to the roundabout?
Yeah, when we design the roundabout, we shoot for a design speed of around 20 to 25 miles an hour. Additionally, but I think I heard you ask the question asked about bicyclists.
Yep.
We provide the opportunity for bicyclists to choices, I would say. A bicyclist who likes to travel fast or travel in the cartway can merge into the traffic stream and merge into the roundabout and the circulatory roadway similar to any vehicle. However, if a bicyclist isn't comfortable with that, they have the ability to use bike ramps that we've installed just prior to the crosswalks. So from running on the shoulder or the outside lane or in the curbed section, we then provide them the opportunity to ramp up and either walk on the sidewalk or ride on the multi-use trail path, and then safely merge back into the traffic stream. And because the speeds are much slower than they would be at a signalized intersection, it's a much more comfortable merge and decision. And we tend to put those decision points near the entrances where the speeds are the slowest.
Will RRFBs be provided for the crosswalks? And yes, the project is proposing to install RRFBs at all of the crosswalks with the roundabout. Will there be traffic lights at Llanberis and Belmont and Clyd and St. Asaphs? So this project isn't proposing to install traffic lights there, but there is some, private development in the works that the township is coordinating that may install, flashers for pedestrian crossings in the future. But that's not part of this project, and that's by the township and part of the, work by others.
Yeah, and we, like you said, Nate, we've been coordinating with the township, so we're aware of it. We're also not precluding that, and as that operations slide show, we check the queuing associated with stopping for those intersections.
Next question, will the crosswalks be synced so that pedestrians will be able to come from one side to the other without having to stop in the small island between the 4 lanes? Go ahead, Mike.
Yeah, the short answer is yes. They're push button actuated. So when the person who's crossing is ready to cross, they will push the button, similar to what you see on Lancaster Ave as well as Presidential Boulevard.
Why has New Jersey systematically eliminated roundabouts and replaced them with traffic lights? Also, we are skeptical that the data favors roundabouts versus turn lanes. And Mike, I think you commented earlier on, why New Jersey is removing the roundabouts. And in terms of
traffic signal.
Yeah, sorry. Yes, thank you, thank you, Mike. Thanks for correcting me. And the second part is also we are skeptical that the data favors roundabouts, and I would say, I mean, you know, the focus of the project is safety, and that's really how we're analyzing this project, is from the safety perspective. And though I think a side benefit is that roundabouts also have, you know, an operational component to them, and it is showing to work on the operational side with all of the future and proposed development in the area. Next question is, what is the timing of the work on City Ave Bridge in relation to the roundabout? So this project is proposed to go out in 2027. My understanding is that work is going to occur before then, but we're going to coordinate with the project team that is doing the work on City Avenue, just to make sure that there aren't overlapping construction stages or phases or detours in place as both projects develop. We have heard about additional lives that will be saved due to slower speeds of cars and accidents with the roundabout, but hasn't been calculated how many additional pedestrian lives will be lost due to the change. I guess, Mike, you just want to comment around how, you know, from a safety perspective and a pedestrian standpoint, roundabouts are shown to reduce, you know,
yeah, I think we had a slide up earlier that kind of tried to address maybe this comment about pedestrian fatalities at roundabouts. And so we're not observing any of that as part of PennDOT's biannual assessment of roundabouts that have been built. We're not showing any fatalities. So I don't want to dismiss the comment, but we're just not, the data is not supporting that type of comment.
Will the stone wall be affected in front of Sutton Terrace? And yes, it will be affected in front of Sutton Terrace. You know, but like Andrew, I think, was commenting earlier, you know, there will be, you know, discussions with property owners for impacts to any property. If, you know, the Sutton Terrace community wants to have the wall rebuilt, that's an option that can be worked out as coordination and design moves forward. Are there plans to provide bike paths? I guess, Andrew, can you just pull up again the slide on kind of the, you know, what we're proposing from a cross section and a connectivity standpoint?
Yeah, go ahead, Andrew. You're muted.
Thanks, Mike. On-street bike lanes are not incorporated with this project, but we are accommodating the separated multi-purpose path, which will be a bike path, and that's following the planned Lower Merion Greenway that's proposed. The widths and the cross sections again are provided by the township's zoning code, and those are being incorporated into this project.
The graphic really does a great job of demonstrating what that cross section would look like. And so not only are we providing sidewalks and crosswalks and rectangular rapid flash beacons, but we have this added benefit of the public multi-use purpose path. And this is really something the township is trying to add connectivity. We're going to see a nice way of crossing the intersection and utilizing it for not only pedestrians but bicyclists, and the purple lines represent that trail network.
So what is the objective of the roundabout? Well, then that's just to improve safety and reduce serious and injury and fatal crashes at the intersection. That's really the purpose of what we're proposing here. You know, I think we touched a little bit earlier on New Jersey, and you know, why not just starting with, you know, signal improvements for this intersection. Next one is, have raised crosswalks been considered? That's not something we've really proposed for this intersection. I think a lot of times those are used to slow vehicles down as they're traversing through a corridor. And, you know, with the roundabout itself, with, you know, the geometric changes that we'll experience at this intersection, that's going to help to slow vehicles down to an appropriate speed already without the raised crosswalks. Have you studied the population living in the corridor? They are not going to be able to navigate the safety area and will not be able to dart through the traffic. I guess, Mike, can you just talk for a minute how pedestrians navigate and how it can accommodate users of all different ages and demographics?
Yeah, I'm not sure I quite agree with the comment, but at the same time, it's about education. And what we're trying to do is enhance the ability to cross the intersection while improving the roadway safety. And so again, by slowing people and drivers down, not only during the peak hour, but the off-peak times, we are allowing pedestrians to only have to cross and navigate 2 lanes of traffic versus 4, 6, or 8 lanes, depending on the situation. So by shortening that crosswalk distance, it provides a slower walking pedestrian the ability to get through the intersection in a much shorter time, while also allowing for the operations to commence and continue. And the rectangular rapid flash beacons will really enhance the ability of vehicles to slow down and yield to those and stop for those pedestrians.
Next question is, how wide will the sidewalks be? Andrew, do you know off the top of your head what the widths we're proposing are for the sidewalk and the path area?
Yes, each width is dictated off of that zoning code, but the proposed sidewalks are going to be 8 foot wide. The proposed purple multi-use path is going to be 8 feet wide. And in our tight quadrant of Sutton Terrace, we have a 5 foot wide sidewalk to not impact the parking circulation of Sutton Terrace.
Pedestrian safety and walkability is very important to Lower Merion and its residents. Although studies indicate that crossings with the median refuge and flashing lights improve yield behavior by drivers, the characteristics of drivers in specific cities has been shown to have an enormous impact on the percentage of drivers that yield to pedestrians. And I guess they're citing a Texas A&M study. Please comment on the driving characteristics of our metro area as it pertains to obeying traffic laws and the likelihood of drivers yielding to pedestrians and cyclists. I guess, Mike, do you have any background on that, of if you've seen in your travels and studies different metropolitan areas behaving differently?
Nate, that's a loaded question. I think we're all observing people speeding at higher speeds. We have larger vehicles that weigh more. I just attended the Vision Zero conference with a few folks on this call, and it is a real concern. And I think just kind of we're adding fuel to the fire here. It's one of the reasons we're suggesting a roundabout is because they're self-mitigating. And I think I saw a question that will either pop up or we already answered. And so in terms of technology or having cameras, speed cameras, things of that nature, the physical geometry of this intersection is going to help self-mitigate those speeds. And again, by slowing the speeds down, people will be able to assess and observe gaps at a much more successful rate. When you have vehicles traveling at 40 miles an hour, it's much harder to judge a gap to merge into than it is at 20 miles an hour. And so I think overall, since the pandemic, we are seeing a lot of increased speeds. And by using the curbs and the deflection and just not being physically able to drive straight through the intersection, we're going to be able to eliminate that speeding at the intersection, which will help aid in the crossing and for the bicyclists and pedestrians. I'm a user of this intersection on a daily basis. I not only drive through it, but I ride my bike through it as when I go mountain biking down in Fairmont Park, and I walk across this intersection when I go to the Acme. So I appreciate everyone's concern, and I strongly strongly urge you to go check out the Walnut Lane roundabout to see how it operates and how the speeds are how slow the speeds are.
How will street names be signed at the roundabout?
Yeah, that's a great question. So we have a combination of signing and striping. The key to navigating a roundabout is making sure that there's proper messaging to be in the proper lane to navigate. At the exits or in those splitter islands, we provide a signage, an exit sign that lists the destination of the roadway. And so that's the simple answer, Nate, is we provide exit signs in the splitter islands at the corner. I don't know, Andrew, if you can point to it, maybe showing the blowing up.
Yeah, bear with me. So signs will be posted at the corners of the splitter islands to let you know.
Go to
if
the
you need
Walnut Lane intersection real quick. I think they may be able to show an example of a sign. Maybe that one with the lighting. Yep. So you can see here, green on white. It has an arrow. It's probably hard to see from this slide, but that's generally how we sign. And the beauty of it is if you miss your turn or your exit, you can take another lap around the roundabout and exit without going out of your direction.
Next question, how is traffic diversion accounted for in the traffic modeling? Congestion on City Ave will divert if the roundabout is successful, thus attracting more traffic. Mike, can you just comment on what we did or didn't include in our traffic modeling?
Yeah, so what we do is we take the existing traffic counts that we gather when we first start the project. We document those, and then we use a growth factor to build up and extrapolate a growth. In this case, we use whatever PennDOT puts out on an annual basis for that roadway context and for that county. And we grow that to a 20-year design horizon. One of the reasons that we're still in preliminary engineering is because we've heard and seen and coordinated with all the additional development. And so that development will inherently bring more traffic or more trips to and from those developments and through the intersection. And so we use what the developers document and put into their submissions, and then we build upon that with our growth rate. Ultimately, we model that 20-year horizon, but we didn't only go that far. We actually extrapolated and did a sensitivity analysis and looked at it out in 30, 40 years. The development of one Belmont also has a 50-year master plan. So we did take that additional traffic into account, and this roundabout will work successfully for a long time from an operations standpoint.
Next question, you indicated that in 5 years there were 37 crashes. How does this compare with other intersections? Andrew, can you go back and kind of retouch on the slide that explains how this intersection was selected?
In slide 10, Andrew. Go back to slide, or sorry, yeah, that one there. Nate, this is a diagram of all the crashes from that 5-year crash period. As you can see here, a lot of rear end and angled crashes. And so because of the higher speeds and the lack of ability to judge those gaps while turning left, I also feel like there's a lot of frustration when navigating the intersection during the peak hours and trying to get through the intersection. If you have one person who is trying to turn left, it effectively does not allow that lane to allow for vehicles to drive through the intersection. And so at the end of the day, we take these crashes and we look at them, and that's what we use the highway safety manual which ultimately is a quantitative way to justify and predict the number of crashes that are associated with different types of improvements, signalized improvements, roundabout improvements. And when we compare that cost benefit ratio, we're seeing a net benefit in and a reduction in crashes and severity of crashes.
Will cameras be installed at each crossing? We're not proposing to put cameras in where the pedestrian crossings are being installed for the roundabout. What about the many emergency vehicles speeding down Belmont Avenue? And I would say those will continue to operate similar to how they operate today. As they're traveling on any road, vehicles will have to move to the side as they approach the roundabout. Vehicles will have to move to the side so that they can get through the road or intersection. How close can a normal intersection be with or without signals? I guess, Mike, can you touch on that quickly?
It's a very case-by-case situation, but what we do try to do is look at how the signal and the roundabout interact, and we look at that in the design year during the peak hour, and that goes back to the other graphic of those cues. And so a closely spaced roundabout to a signalized intersection could be problematic, but in this case, our intersections that are signalized or proposed to be signalized are spaced far enough out where the worst 15 minutes of the day, the queuings aren't going to affect the operations of the roundabout, and vice versa. The roundabout won't impact the upstream and downstream signalized intersections.
What additional street lighting is needed for roundabouts and crosswalks? And lighting is recommended for roundabouts that are being installed, and there's a lighting analysis that the design team will need to complete to make sure that the area is being lit properly. Will there be accessible pedestrian signals for all crosswalks per ProAg guidelines? Yes, we're going to meet the criteria for pedestrian accessibility and ADA guidelines for the crosswalks and curb ramps within the project area. Who will make the final decision to leave as is or move to a roundabout? I would say it's a shared decision between PennDOT, the community, the township, and other stakeholders in the area. We really want projects to be successful. We want them to be supported by the community. So that's part of what part of the reason for this meeting tonight is to go over the proposed improvements with the community, to get feedback on the project, to see if there are improvements that we can make, anything that we should be doing differently. So I would say it's a shared decision between different parties, but again, the focus of this project is on safety and reducing crashes. That's really what we're trying to achieve with proposing a roundabout at this intersection. If entry speed is designed for 15 to 18 miles per hour, as shown in the descriptions, and traffic now travels at double that, what will be done to reduce the speed on the roads leading into the roundabout? Mike, can you talk on some of the entry and exit geometry and what that does to reduce speeds?
Yeah, by providing the deflection and the raised curbing, we're just not seeing the ability to. What we do is a fastest path check with our geometry. And so again, we try to accommodate the larger vehicles, but at the same time, we don't want the other passenger vehicles speeding through the intersection. And so the visual cues associated with some of those curvatures and the curbing and narrowing the lanes down inherently provides the ability for a driver to assess that they're going to be navigating the roundabout and slowing down.
Additionally, on the approaches, there's advanced warning signs that a roundabout is ahead.
During rush hour, the lights at City Avenue present crossing problems. One lane goes right, one lane goes left in the center. straight creates a backup. With this roundabout, will a backup create further problems?
Yeah,
Mike, can you just
Nate,
touch on this
there's
again?
just not, in order for pedestrian volumes to impact the operations, it has to be over 100 pedestrians per hour is where we're starting that threshold where it would start affecting operations. And we're just not seeing that type of pedestrian crossings. You know, a good example might be at a university or a school where we have a large number of pedestrians crossing in a concentrated amount of time.
Next question is, won't increased traffic make entering the roundabout a challenge?
Can you say that again, Nate?
Won't increased traffic make entering the roundabout a challenge?
No.
Maybe with
Yeah, and I think kind of what, the analysis shows is that, the roundabout is able to handle the volume that's coming through the intersection, that vehicles will slow down, even as development happens, as maybe some traffic patterns shift, the roundabout will be able to handle the increased traffic to be able to accommodate vehicles traveling through the intersection. Next is on property impacts, and I guess it's just kind of wondering, what that looks like. And that's something that's, in the future as the project moves forward, for any property that's impacted, there is a right-of-way process that PennDOT goes through where there's discussions and negotiations with property owners, where we try to reach, work towards an amicable resolution to any impacts to a property. Next is PedSafe information clearly states roundabouts are typically not appropriate for the intersection of two multi-lane roads, but all the illustrative materials show exactly that. And I don't think that's kind of what, PennDOT or FHWA has seen in their review and analysis of roundabouts, is that it is showing a reduction in crashes and it to be safer for all modes with the reduced speeds. And we're getting a little short on time. We're going to go till 8:45 tonight and get through as many questions as we can. So if I'm skipping a question, it's most likely because we've kind of touched on it earlier. If we get to 8:45 and we haven't covered all of the questions, we do have the comment form online that you can leave comments. You can also reach out to us after the public meeting for more discussion around this project if you have more questions and then want to talk in more detail. How long is construction supposed to take from start to finish?
Yeah, we haven't really finalized the durations. We're contemplating strategies associated with building the intersection. Andrew went through a few options of fully detouring versus partial detour. Obviously, if we are able to close the intersection down completely, we'll be able to incur a savings, but also a shortening of duration. If that's not something PennDOT and the township are willing to, and the community is willing to handle, then we will probably look at a phased construction, which I think is safe to say, depending on when we advertise it for contractors to bid on, 1 to 2 construction seasons.
Okay, next question, I'll try to summarize a little bit and focus, I think, on the question. But Mike, can you touch on, once the roundabout is constructed, how driveways or roads further away from the roundabout would be affected?
Yeah, so again, we're anticipating slower speeds at the intersection, but just with any other intersection, as you gradually get farther and farther away from the intersection, it's really hard to predict how fast they'll be going or how, and and how the access points. But one thing is clear is that we're improving access at the intersection for the residents and the businesses near the intersection, because they'll be able to use the roundabout to their advantage to do U-turns or left turns through the roundabout. And so if you're not comfortable turning left out of your community or your house or your business, using the roundabout to your advantage to turn right and then go through it and head the opposite direction is a huge benefit.
The next couple are kind of similar in the flow of driveways, close to and farther away the roundabout. What maintenance is required for the roundabout? Green in the center versus sight distance. So a lot of the features that you might see around a roundabout, what's in the middle of the roundabout, are determined by the municipality in the area. So that's something that we would coordinate with Lower Merion Township on what it might look like in the middle. But Mike, can you touch on what the thinking is for how to, I guess, mound or not mound what's in the middle of a roundabout?
Yeah, so the inner circle is that green circle. It has a what we call a truck apron, which is a mountable curb to help with that over tracking for the larger vehicles, but still narrowing the lane and providing that deflection we need to keep the speed slow. Additionally, we want to mound and provide some sort of visual obstruction in the inner circle. So when people are entering the roundabout, they're focusing not, and Andrew, please use your cursor here. We want them to focus at the task at hand, and that's focusing on the upstream traffic or this traffic approaching from the left. Rather than someone, let's just say northbound on Belmont, focusing on southbound Belmont entering. And so by mounding and providing landscaping, which is a great gateway opportunity, not only for the township, but for the community, is we're restricting sight lines through the intersection. So drivers are focusing on the immediate decision points, which is the merging into the circulatory roadway.
Mike, can you also touch on, to the next question is around that, drivers will be focused on cars in the roundabout and not on pedestrians. Can you go back and show kind of that staggered, two-phase approach?
Yeah, so current best practices really show that staggering the crosswalk away from the yield bar is the best way to handle this, and that what we're trying to do is segregate the decision making of the driver as they're approaching the circulatory roadway. We want them to first focus on the pedestrian crossing, and once that is clear, then they can move forward and then focus on entering and yielding into the circulatory roadway. And so we typically provide enough for 1 to 2 car lengths between the yield and the crossing. However, the farther we push that crossing back, the less likely it is for a pedestrian to navigate farther and farther away from the intersection. So it's a balancing act, but we stagger the crosswalk from the yield bar for those distinct reasons.
And I think some of the next questions were similar to ones that we answered. So I'm going to go to, if this relatively complex roundabout is received poorly by the community traveling public, is there a concern that getting support for future roundabouts in the region may be more difficult, even if other locations may more easily support a simpler single lane roundabout? And I think PennDOT is really, they're aware of that. And they're, that's why PennDOT is really committed to making sure that any roundabout, single multi-lane that gets installed is, vetted, is properly designed so that it is successful, because, we realize that if it is not successful, it could impact, the ability to install more roundabouts at different locations in the future. So there is a focus on that. It is recognized by PennDOT, and that's why, you see PennDOT, building roundabouts, continuing to study the statistics from those roundabouts to understand how they're operating, and make improvements to other roundabouts in the future. So that is a definite, item that PennDOT's aware of, and that's why we're focusing on not just this roundabout but other roundabouts to make sure they are designed properly and operate properly and are safe for all modes of transportation.
Well said, Nate.
Let's go to, will there be dedicated bike lanes which don't appear on the current slides? I guess, Andrew, can you go back and maybe Mike or Andrew just touch on, how the bikes will operate there?
Yeah, so current best practice is not to include a formalized bike lane in the actual roundabout itself. Again, near the crosswalks, we provide the opportunity for a bicyclist either to, one, remove themselves from the cartway and use the pedestrian crossings and bicycle crossings, or to merge into the traffic stream where the speeds are the slowest and navigate the roundabout as if they were a motorized vehicle, and so that they take over the lane. Andrew, did you have anything you wanted to add?
No, not other than the fact that we are accommodating like the township's ultimate goal of the corridor of having a separated multi-purpose path from the traveling public. It's going to be at sidewalk level. So this project is accommodating that future plan of the township.
I just wanted to give about, I think we have 9 more minutes left in the meeting tonight. We're going to do our best to get as many questions as we can, but just a reminder, there is the comment form on the website, and there is contact information there for me as well. If you want to follow up after the meeting, please reach out. Will access to Fairmount be via Conshohocken State Road during construction? I guess, Andrew, can you just go over again the MPT setup? And I'm not familiar with the second part of that question to be able to.
Yeah, can you read it one more? Yeah, I'll try to find it on the chat.
I guess the question was around, will access to Fairmount be via Conshohocken State Road during construction?
Yes. When St. Asaphs Road is detoured, they'll have to utilize Route 23, which is Conshohocken State Road. At the Fairmount, I'll use the red laser pointer here. The Fairmount condominiums are located at the intersection of St. Asaphs, or near the intersection of St. Asaphs and Route 23.
Next question is, how will deflection slow speed for 2-lane roundabout?
How will the speeds? We inherently we design them for a curvature. So again, it's almost like if you were to put your eyeball down onto the plan sheet and look straight through the intersection, there is a wider pavement. So acknowledging that the multi-lane has a wider pavement section, that is true. But we still provide those deflections. So if you were to travel through the roundabout going westbound on St. Asaphs, we'll say, you can see you have to turn the drivers will have to turn their wheel to the left and then to the right as they cross the yield bar, and then again left. And so it's a type of chicane movement, and those radiuses and that geometry is built and will be constructed to physically not be able to drive straight through the intersection.
And Mike, is it fair to say that when we're looking at the fastest path through a roundabout, we're not focusing on a vehicle staying in its lane, but we're drawing the fastest path where it could take up as much of the pavement as it wants to?
That's correct. When we do our fastest path calculations, which is really trying to see how fast a vehicle can drive straight through the intersection, ignoring lane striping, we have to document that the design will accommodate slower speeds. And again, it's the eyeball test. If you put your eye down and look at it on a piece of paper on the table, we just wouldn't be able to draw a straight line through the intersection. And that really is a very I guess, quick and easy way to show an effective roundabout design.
Next question is, at times of low traffic, a roundabout will keep traffic flowing, but at times of high traffic, I'm not sure, in both the morning and evening rush hours, there's a heavy load of traffic in all four directions. Traffic might just stop. What happens then? And I think, some of the stuff we talked about earlier and the analysis that we've done, is kind of showing that the roundabout will continue to move traffic even in those high traffic periods. And, just a reminder that when we're, the traffic information, the modeling that we were showing tonight, is based on the year 2047, right? So even, over 20 years from now, it's still showing to operate, at an acceptable manner with queues and delays in the area.
Yeah, and injecting the proposed developments, additional trips.
Are you aware of the amount of ambulances and fire engines that rush down our street on a daily basis? Has that been considered?
Yeah.
And go ahead, Mike, sorry.
No, it's a really good question. And I think when we talked about accommodating for the larger vehicles, we are aware of emergency responses needs. We have had discussions with the police and emergency response folks. And so we are aware, and those WB 62 with the 53-foot trailer are really the worst case scenario. As Andrew mentioned, it's really the largest vehicle that has the most restrictive turning radiuses and the largest envelope, we'll say, that we need to accommodate. So as long as we're accommodating for the larger vehicles that we document for, the police and fire vehicles will be adequately be able to navigate and navigate the roundabout.
How will you train people to use the roundabout properly? I've seen people going the wrong direction on the new circles in Fairmount Park near the Police Touch Museum.
Yeah, so it starts with tonight's meeting, right? We're trying to educate the folks on the call here today to understand why a roundabout and the benefits associated with it from a safety, operations, and access standpoint. Negligent driving is always something that we try to inherently build into our designs, and especially during the non-peak times. But we reinforce the design with signing and pavement markings to really message the appropriate way to navigate the intersection.
And Mike, those circles at in Fairmount Park are compact with no splitter islands, so it makes it very easy for aggressive drivers to do that.
Yeah, I think there's lots of different flavors and feels and shapes of roundabouts. They don't always have to be circular, but again, trying to accommodate a design that slows speeds down while also accommodating for the large vehicles is the key. The ones in Fairmont, I would classify as compact roundabouts, as you mentioned, Andrew, and they don't have all those design features and attributes that we're installing in this intersection.
We've got about 2 minutes left, so I'm just trying to see if there's any somewhat different questions. I guess, what will the impact and cost be to utilities and utility poles? I guess, can you touch a little bit on the utilities in the area?
Yeah, so we're still in preliminary engineering. We have all the utilities laid out on our plans. So the utility conflict resolution is going to be part of our final design exercises. So at this time, we don't have a cost to that. And also the extent of those relocations is going to play a factor into the overall construction schedule as well.
Isn't this plan exactly opposite of what the township is doing by removing triangular pedestrian stopping points on Montgomery? I can't say I'm familiar with what the township is doing, but we can always, discuss it with them and see what they've been doing in that area.
Nate, I'm familiar. I think what she is being referred to as the skewed intersections where there's an acute angle. And so I don't think it has similar context to this. although we're providing deflection and not allowing vehicles to drive straight through the intersection, one of the things that we really keen in on is making sure we accommodate the sight distance lines that are needed to adequately navigate, to properly stop and have intersection sight distance as well. So we are not skimping on any parts of that design and have made sure that we meet all the criteria. The intersections I think that are being referenced are ones that have really poor intersection sight distance, and so they're trying to navigate some of those safety concerns associated with those poor sight distances lines.
We are at 8:45, so we wanted to wrap up the discussion this evening.
Nate, there was a positive comment. I think it's worth mentioning or ending it where there at 8:40. There was a thank you. I don't know if you want to read it, but
go for it, Mike. If you have it on your screen, go ahead.
Yeah, sure. Just says, I just want to say thank you. I felt that I was taking my life in my hands walking through that intersection. What a messy endeavor while being built. I believe that it will be a contribution to the community in the long run. I appreciate the comment. And although I know it's difficult for us to speak and answer questions in this type of format, I really appreciated all the questions. I think it is an educational process, and it starts like with meetings like this one today. So I hope we did a good job of answering your questions. Nate, maybe you want to plug the comment card.
Yeah, so I mean, again, if you go to the project's webpage, there is a comment card where you can continue to make comments, provide feedback, reach out if you have additional questions around this project. Also, this presentation and Q&A tonight will be posted on the project webpage. So if there are others who couldn't make tonight's meeting, please send them the link to the webpage and keep an eye out for the recording. So if they want to review the presentation and provide comment, they can. I definitely appreciate all the feedback. We're going to take the feedback that we received today and discuss it, with others at PennDOT and the project team. So again, thank you for your feedback. Please continue to make comments if you have, everybody, and we definitely appreciate the time from everybody this evening to listen to us and to provide comments on this safety project. Thank you, everybody. Bye.
Thank you.
Thank you.